is the unit circle. Uh, as you can see from the diagram, the unit circle is a circle with center 0, 0, which is also called origin, and radius 1. And the equation of a circle is x squared plus y squared is equal to 1. Don't worry about this equation of a circle at this point. So if you look at the unit circle, so this is the one thing which I would like to tell you is that as we are going through this lesson, I will highly recommend you to take notes. So when you are drawing in angles in the standard positions, then the angles which you draw is different than the bearing. If you remember, the bearing is always with respect to north and it's in clockwise direction, whereas the angle is always measured is positive when it's measured in anti-clockwise direction, as you can see here. So this is called the initial side, this is the terminal side, and then the theta, as you can see, the direction is anti-clockwise or counterclockwise, which means that this theta will be positive. Whereas if you have this as the initial side and the terminal side is in the fourth quadrant, as you know that this is called x and y here, this is called first quadrant, then second quadrant, and then this is third quadrant, and this is fourth quadrant. So just to note down, this is called first quadrant, this is your second quadrant, and this is your third quadrant, and this one is your fourth quadrant. And the quadrants are also in anti-clockwise direction. And here this is initial side, this is terminal side. If you measure the angle which is in the which is like this, then it's going to be negative. So now here, for example, if you have angle theta, which you have to draw is 40 degree, then your theta 40 degree will be like this. Theta 160 degree will be in the second quadrant. Theta 40 degree is first quadrant, is an acute angle. Acute angle means when angle is between, the value of angle is between 0 to 90. When theta is negative 320, then you will start from fourth quadrant. And as you know, the complete revolution is 360. So you will go here, this gives you negative 270, and then 50 degrees more, which means this from here to here is negative 320. So you can try these problems. So take a pause here, and then you don't use a protector for this one. So just to get an idea, theta 120 degree, which means that it's going to be in second quadrant. So 90 and 30, so 120 degree will be there. So give it a try. So especially theta 750, how would you draw that theta 750? You remember that a complete revolution is 360. So for 750, you will have two complete revolution, and then you will come back to first quadrant here. But give it a try. Then you also know, if you know that we did a special right angle triangles, we talked about 45, 45, 90, and then we also talked about 30, 30, 60, and 90. And I hope that you remember the relationship between when you have 45, 45, 90, and when you have 30, 60, and 90. So we'll be using that to find out the values for this unit circle for specific angles, which we'll talk in a minute. So here, so this is called, this is for multiples of 90. So if you have 0 here, then 90, then 180, 270, and then 360 will be back here. So this is the multiples of 90 here, the multiples of 30. Again, I will recommend you to actually sketch this in your notebook. And multiple of 30, so 0, 30, 60, 90, 120, 150, and so on. And then multiples of 45 is this one. So 45 and then 225, as you can see, that they are the two different, they are opposite to each other. So 45 is in first quadrant, 225 is in the third quadrant. And this is the multiples of 60. When we put them all together, so what we did here is multiple of 30, 45, and 60. And as you can see, some of them will be common. So for example, here you can see 60, which is a multiple of 30 as well as multiple of 60. And then 90 is also a multiple of 30, is also a multiple of 45. So we are going to combine this to draw a unit circle with all of these values. So what we are trying to find is that we want to find the value of the coordinates x and y coordinates for all of these angles. So for 0, for 30, 45, 60, and so on. So this is what is the aim of today's lesson, that we try to find out. So what I'm going to do is I will show you how to do it for the first quadrant, and then you have to do for the second, third, and fourth quadrant. That will be a part of your homework. So that's what you need to do. So I'm going to start with the first quadrant, but before you do, and I will be doing a little bit of other values also, the values which is quite obvious to do. For example, if you look at 0, because it's a unit circle, so we know that this is 1 radius, and we know that this is also radius, and this is -1 because this is negative x-axis. And then so we know that if I want to find the value corresponding to 0, this coordinate is going to be, what will be that? Because x-axis y is 0, so 1 comma 0. This one with respect to 180 degree will be -1 comma 0. This value will be, because here this is on y-axis, x is 0, so 0 comma 1, and this value will be 0 comma -1. So as you can see in this table. So all these values, the values which was very, very easy to find out. So we filled out that information first. So we know that for 0 and 360 is also, it's going to be same, as 360 is again at the same position. And then 90, 180, and 270. Okay, so when try to kind of like keep these values in your mind, because this is very useful. We'll be using them in the follow-up lessons, which will be solving trigonometric equations. So make sure that you know. And also, actually, we will be using these values to sketch the trigonometric functions. So now we need to do the first quadrant. So I'm going to move to the first one. So if you remember when we did 30, 60, 90 degree angle, so what I'm going to do here is I will just recall very quickly. So if you had, if you remember, we started with an equilateral triangle. So this is 60, this is 60, this is 60. And then I drew a line, a perpendicular actually, from here, perpendicular bisector, if you remember. And then this angle is 30 degree. And then this one was 90, and this angle is 60 degree. So if you remember, the relationship was, so if you have 30 and then you have 60, and 90. So we know that the side length opposite to, because we started with 2a and then this was a and this was 2a, and then we got this using Pythagoras theorem, and we got this as square root of 3a. So the side length opposite to 30 was a, and then opposite to 60 was square root of 3a, and then it was 2a. So if I don't want to use a, or you can leave as a, but the ratio is 1 is to square root of 3 is to 2. And remember the corresponding angles. Now in this case, what is happening is we have this, the whole thing as 1, and then this is 1, which means our 2a is 1, if you can see here, because the angle opposite to the side length 1 is 90 degree, which means 2a is equal to 1. So if 2a is equal to 1, which means my a, which is equal to half, and which means if a is half, so which means this side length, this one is half. And now only thing I need to find out is this, and this is square root of 3 times half. So this will be square root of 3 divided by 2. So square root of 3 divide by 2. So that is the side length here. Now this angle, now we need to find out what is the coordinate of this. So before we do that, but remember we got square root of 3 over 2, which is your y coordinate. So that is your y coordinate. And 1 over 2 is your x coordinate. So you got 1 over 2 as your x coordinate. So we found corresponding to 30 that this is going to be half comma square root of 3 over 2. Now the another thing which I would like you to show is, if I have a right angle triangle, let's say like this, because here this is corresponding to 30 degree. So if I draw it like this, the right angle triangle here, and let's say this is any angle theta, then and if this is the unit circle, so this is 1, which means this side is opposite, this side is hypotenuse, and this side is adjacent. And if you use SOHCAHTOA, since it's a right angle triangle, then sine theta is equal to opposite over hypotenuse. And opposite in this case is, let's say O, and this is 1. And let's call opposite as your y. And then adjacent is your x. So if this is the case, you can see that y is equal to sine theta. So your y coordinate is for the unit circle is sine theta. And similarly, you can find x, and if you again use SOHCAHTOA and cos theta this time, cos theta is equal to adjacent over hypotenuse, and adjacent is x and hypotenuse is h, and which in this case is 1, which means x is equal to cos theta. So always remember that your x is cos theta, y is sine theta, but make sure that, so here, this will be cos 30, and then you will have sine 30. And then this, in this case, will be sine of 30 degree. But always remember, this is cos and sine if the angle 30 is with respect to x-axis. If angle 30 is not with respect to x-axis, this won't be any more cos 30 and sine 30. So you always have to pay attention to. If the angle is with respect to x-axis, then your x coordinate is cos of that angle and y coordinate is sine of that angle. So we know, now we know the coordinates of this. So we know that cos 30 in this case was, because the coordinates which we got here was, if you remember, the coordinates you had in this case was cos 30 and sine 30, and cos 30 in this case came out to be square root of 3 over 2, and sine 30 will be, sine 30 was 1 over 2. So we found that. I already explained all of these things, so x and y. So I already explained in a 30 60 90 the length of the hypotenuse is twice the length of the shorter leg, and the length of the longer leg is square root of 3 times the length of the shorter leg. So we already know that. So I already explained all of these things, and then this is how we got the values. Now, after that, we now need to move to the 60 degree. Now, if you have this as a 60 degree, how much is this and how much is that now? Now, in this case, what is happening here is you have hypotenuse, again, 2a is 1. So I'm not going to recall that again. So you can go back and see if you need to review again. So a is half. And now what is a half here? So a is your opposite to 30 degrees. So this is opposite to 30 degree is your a, right? So sorry. Okay, so in this case, what will happen is your y will become square root of 3 over 2, square root of 3 over 2, and x will be your half here, because now you have angle 60 here, which means this is 30. So opposite to 30 is going to be half now, because a is half of what you have as a hypotenuse, which is 1 in this case. So x will become half, and y in this case will become square root of 3 over 2. So now it's a switch. So if you remember, for 30 degree, x was square root of 3 by 2 and y was half, and for 60 degree, x became half and y became square root of 3 over 2. So this is your cos 60. I will be actually I will record that in this case x is cos 60. Let me write down. So in this case, x is, my x is, again you can go back and see why x is cos 60 in this case, and we got this value is equal to 1 over 2. And then y in this case is sine 60. Again, the angle has to be with the x-axis. So this is equal to square root of 3 over 2. The explanation is, I already explained it, it's a similar thing. So we found the values corresponding to 60 also. So this is the values corresponding to 60 degree. And now we need to do the same thing for 45 degree reference angle. So again, a quick recap. For 45 degree angle, if I draw a right angle triangle, let's say this is right angle triangle, and then if this is one and right angle triangle and a special right angle triangle where you have this side equal to this side, which means this angle is 45 and so is this angle. So this is 1 and 1, and then this becomes square root of 2. So now using this thing, now we need to find out for 45 degree. I'm going to show you here. So what happened here is, we already know if this is 1, then this has to be, recall that. Let's try to recall again. So if you had, if you remember, so we had this as, we said this one was, sorry, we said this one was, this is equal to this. No, yes. And then, okay, So this one is equal to this. So this is 1, this is 1, and this is square root of 2. Let's say square root of 2a. And then let's call this as a and a, which means square root of 2a in this case is your 1, which means what is a? A in this case, because it's a unit circle, so square root of 2a is 1. So 1 over square root of 2, which means this is 1 over square root of 2, and y coordinate is also 1 over square root of 2. And again, recall x is your cos 45. So your cos 45 is equal to 1 over square root of 2, and sine 45 is equal to 1 over square root of 2. So these two values are equal. Cos 45 is equal to sine 45, and both of them is 1 over square root of 2. So I explained all of these things again. Now, after that, we already found this value, and 1 over square root of 2 can also be written as square root of 2 divided by 2. I hope you know that, but I'm going to show that quickly. So if you have 1 over square root of 2, you can rationalize it. And when you rationalize whatever is in the denominator, you multiply by numerator and denominator. So this is square root of 2 divided by 2. So it's the same thing. 1 over square root of 2 is same as square root of 2 over 2. No difference here. Now, so I filled out all the information for the first quadrant. So we know this one was 1, 0. This one was square root of 3 by 2, 1 over 2, square root of 2 over 2, square root of 2 over 2, and so on. And I also gave you the value for 180 and 270. So what I would advise is the way I was saying it, when I was finding the values for these 30, 45, 60, 90, for 90, 0 and 180, 270, 360, we didn't find the value like that. But what I would like you to do is you go back and write down that x is equal to cos theta, y is equal to sine theta, when theta is an angle with respect to x-axis, which means here I will translate these coordinates in terms of cos and sine values also. So I will write down cos 0 is 1 and sine 0 is 0. Cos 30 is square root of 3 over 2. Sine 30 is half. Cos 45 is square root of 2 divided by 2. Sine 45 is equal to square root of 2 over 2. If you will not take notes, you will have difficulty with this section. So please make sure that you take notes as we go through today's lesson. Now I'm going to move to the trigonometric ratios, which we already know. There are 6 trigonometric ratios, but we are going to focus on 3. And before I move to that, I also want to tell you one more thing here. So if you have a unit circle, we know that x is equal to cos theta and y was equal to sine theta with respect to theta, which is with respect to x-axis. So then, if that is the case, if you go back here, you can see from here, so if this one is cos theta and this one is sine theta, so if this, because I have to draw a line here, so this is sine theta, and we know that this is unit circle, and using Pythagoras theorem, I can derive that sine square theta plus cos square theta is equal to 1. So sine square theta plus cos square theta is equal to 1. This is the first trigonometric identity. This is called trig identity. This is the first trig identity which we introduced using unit circle. One more thing, if you have, what does sine square theta means? Sine square theta is the notation which we use to write down sine of theta whole square. So we don't write sine theta whole square, or we can start with sine theta whole square, but this is the notation which we use for sine square theta or cos square theta. So make a note of this also. So we introduced one trig ratio here. And similarly, the equation of a circle, which I said in the beginning that, you don't have to worry about it. But then, as you know, if this is x and this is y, this line, and then if this angle is theta, in this case is 30, then x squared, again using the Pythagoras theorem, x squared plus y squared is equal to 1. So you can easily prove the equation of a circle using Pythagoras theorem, that x squared plus y squared is equal to 1 for unit circle. But if instead of unit circle, let's say that if you have a circle with center 0, origin, and then radius r, so you don't have now 1 as a unit circle, but it won't change anything except your x in this case will become r. So it's r cos theta, and your y will become r sine theta. So that's the only difference. In this case, our r was 1, but if it's not a unit circle, then your x and y will become this, and then the equation of a circle in this case will become, because x squared plus y squared has to be 1, so that will be cos squared theta plus sine squared theta, sorry. So sine squared theta, so you will have here r square, because instead of, sorry, so you will have, now you have this as cos theta sine theta, so you will have cos square theta, or x square plus y square is equal to r square. Okay, so right now this will be your equation of a circle here, and this is for center 0 0. This is for center 0 0 and radius r. Now I'm not going to touch on when the center changes what will be the change in the equation of a circle. If you are interested in, I will just give you the equation here. The equation of a circle, if your center is not 0, which we don't need at this point, but I'm going to mention it. So x minus h whole square, y minus k whole square is equal to r square. Now, what is h and k? They are the center. So h and k, they are center. So these are the center, and r is your radius. So r is radius. R is radius. We won't need this for this one, but I thought it would be a good idea, especially when you are taking SAT, you may need this information. Okay. Now moving to the 6 trigonometric functions. I'm not going to, we don't have to focus on all 6. In grade 10, we are going to focus on only 3. So we already talked about cos theta, sine theta, and then tan theta. I'm going to talk about what is the relationship between sine, cos, and tan in a minute. I will talk about that. So there are another 3 more, which is one is cosecant theta, which we name as CSC, and then you have secant theta, and then you have cotangent theta. So cosecant theta is reciprocal of sine theta, secant theta is reciprocal of cos theta, cot theta is reciprocal of tan theta. Why I'm mentioning all of these 6 trig ratios, even though we are going to focus on only sine, cos, and tan, the reason is that those who wants to challenge themselves and trying art of problem solving questions, you might see the questions based on cosecant, secant, and cot. But it's a very simple thing. Cosecant is just the reciprocal of sine, and secant is just the reciprocal of cos, and then cot is reciprocal of tan. And this is the relationship which I was talking about, the relationship between tan, sine, and cos. Tan theta is equal to sine theta over cos theta, which I'm going to show you in a minute. So I hope this is clear. This I already explained. When you have r squared, this is what is going to happen. We already know sine, cos, tan, so nothing new here. Okay, so that's pretty much here for this one. So what I'm going to show you now is the, okay, here. So the relationship between sine, cos, and tan. So I drew this diagram on GeoGebra, and I will try to explain. So here, as you can see, in this one, so if this angle is theta, let's say this is theta, so pay attention to this this triangle, the small one, and then the big one. Both of them are right angle triangles, and if you look at, they are also similar triangles. But if this is theta and this is a unit circle, again I'm talking about a unit circle, so this is 1, and we know from A to E, so A to E, this is also equal to 1, and A to C is also 1, and the reason is it's a unit circle. So we already know that. So if I look at the small triangle, what is your theta here? We already know that is your cos theta, and this is your sine theta. So we know that this one is cos theta and this one is sine theta. And now if you look at, so what I did here is I drew a tangent which is passing through E, and if you look at the big triangle, and if this is theta, this becomes opposite, and this is your hypotenuse in this case, and this is adjacent, and you know tan theta is equal to SOHCAHTOA. Tan theta is opposite SOHCAHTOA, opposite over adjacent, so that will become DE over adjacent, and adjacent in this case is going to be 1 because it's a unit circle. So your DE is equal to tan theta. and we already know that this is equal to sine theta, this is equal to cos theta. If you look at these two triangles are similar to each other, which means what? That their side length has to be proportional to each other, right? So which means if you look at, if I set up, because this is theta, so which means tan theta divided by 1 has to be equal to sine theta divided by cos theta. So using the similarities, you know that similar triangles means that they are similar triangles, they are right angle triangles, and the only difference is the proportion between the side length. So we knew using the Pythagoras theorem that this was tan theta, and we know using the Pythagoras theorem that this smaller one is cos and this one is sine theta. So using the similarity, we know that tan theta divided by 1 has to be equal to sine theta over cos theta. So this is how we find out that tan theta is equal to sine theta over cos theta. This is not the only way to do it, but I like to do using the similarities. And I hope it is clear that why tan theta is equal to sine theta over cos theta. So this is what, just to recall what I did is we started with unit circle and I gave you the values for the first quadrant corresponding to 30-degree angle, 60-degree, 45-degree angle. And then I also gave you the coordinates for x-axis on the positive side, x-axis on the negative side, y positive and y negative. And now what you have to do as a follow-up task, the task which you have to do for today is this. So I am calling this as the homework. This is the homework which will be due on 30th of April, since we'll have next lesson on 1st of May. So I already did for the first quadrant. So what you have to do is fill out the coordinates of quadrant angles in the second, third, and fourth quadrant angles, and make sure to show all of your thinking. So I gave you the thinking space here. I'm going to make a copy for each of you so that you will have your own copy. And then remember, tan theta is sine theta over cos theta, and then you have to fill out this information using x is cos theta, y is sine theta, and tan theta is sine over cos theta. So you have to fill out all the values in this table. That's a part of your homework, or you start classwork after this Loom video. And then this is what you have to fill out: signs of sine, cos, and tan. So what can we say about their signs in each quadrant? So I want you to do that, and then I want you to find out what is sine 90 minus theta. So this is like a generalization, but before you do that generalization, I will strongly recommend you to go back to your table here and try to find like what do you notice from? Do you see any kind of a pattern here? For example, I gave one example here, or I just gave you a hint that sine 45 is same as cos 45, and we were doing, then also I talked about this thing. So go back and see that what else can you see, can you find out from the table. And even better, if you can do something with respect to, like, first quadrant. In first quadrant, your angle will be 0 to 90, and then second quadrant is 90 to 180, and then you have 180 to 270 in third quadrant, and 270 to 360 in the fourth quadrant. So have a look at and see that. Don't worry if you won't be able to find out this thing, because my second task will be followed up on this one. So give it a try. So this is your this will be your classwork come homework for today. Thank you.